So welcome to the third session on probability. So we have been discussing about the basics probability, and then we use the principle of counting, that is NCR and NPR, to find the probabilities, to form the sample space and find the even space and thereby calculate the probabilities, correct? Then we close the last class with a discussion on conditional probability, that is P of BA. That is what this means in the English language is what probability of B, probability of B occurring having A occurred. This is what it means, and we proved that this is nothing but probability of A intersection B by probability of A. See, this is common sense, right? We will see one quick example and understand that. Say that I am throwing a die. So what are the possible outcomes? 1, 2, 3, 4, 5, 6 is my sample space for throw of a die, dice throw, correct? Now I say that I should get a even number. This is my even numbers. Now what is the probability? The probability that we get 6. This will be what? To get 6 on a throw of dice, it will be 1 by 6, correct? Yes or no? Now what is the probability that we get 6 if the dice throw resulted in an even number? What? Now I know for sure that when I threw the dice, only even number came. This is told to me. This is told to me in the problem. If the dice is thrown and the result is an even number, what is the probability that I will get 6? So now the possible outcomes are itself only 3. So out of which 6 means it is 1 by 3. Correct? Yes or no? Now let me say that 3, 6. These are what? Multiples of 3 in outcome of die. Outcome of dice throw. Now what is the probability of getting 6 if the dice resulted in a multiple of 3? Means what? The dice resulted in a multiple of 3. So totally itself there are only 2 outcomes possible, out of which 6 is one of the outcome. This is the probability of getting 6. So this 1 by 6 what we are discussing is the case of a general probability. These 1 by 2 and 1 by 3 what we got are the case of conditional probability. This is what is the conditional probability. Clear? Fine. So with this as introduction, let us proceed further. Okay, this is a problem. A bag contains 5 defective, within bracket it is given, immediately fail parts, 10 partially defective and 25 healthy parts. Partially defective means fails after 2 hours of working. Okay. Now the question is, what is the probability that the part is a healthy part if it did not fail immediately? See, so what is asked you is, you have totally so many parts, out of which 25 are healthy. 10 are 10 are partially defective. Partially defective. 5 are defective. Totally there are 40 parts. Totally 40 parts. In total. Clear? So what he is saying is a bag contains 5 defective parts which will immediately fail. That is, I take it and use it, it will fail immediately. 10 partially defective parts means it is going to fail after some time. After 2 hours of working it is going to fail. 25 healthy parts are there. What is the probability that the part is a healthy part if it did not fail immediately? So what he is saying is it did not fail immediately. This is told with certainty. That is, you took a part and you made it work. Let me write this clearly. This is told certainly. You took a part and you tested it. Immediately it worked. That means it has not failed immediately. That means you have not picked from this 5 defective part. You have not picked from this. You have not picked from this. You have picked something from here or here. You have picked something from here. The question is, what is the probability that it is a healthy part? See, if I directly say that what is the probability that I pick healthy part, it will be 25 out of 40. This is generally. Correct? Whereas the part did not fail immediately. That means I am sure it is not defective. It may be healthy or partially defective. Correct? If I simply ask you without this statement, only what is the probability that a part is a healthy part means what? Probability of healthy will be number of total by number of healthy. Correct? This is nothing but 25 by 40. But what is told? Part did not fail immediately is told to you. That means you have picked one among this 35. And the probability that it will be a healthy part will be 25 by 35. So this is what is a conditional probability. That is probability, if I write healthy, given it, probability what? We wrote the conditional probability equation, right? Probability B or A is nothing but probability of A intersection B divided by probability of A. Correct? So probability that healthy, given that did not fail immediately, is nothing but how much? Probability of healthy intersection did not fail immediately by probability of did not fail immediately. So that is nothing but what? Totally 35 components are there, out of which these are 25. So that is nothing but 25 by 35. Clear? This is a classical case of a conditional probability. Okay, so this is our next question. Probability that company in which Mr. X is working will open a foreign branch office is 30%. If it happens, probability that Mr. X will be the head of that office is 60%. What is the probability that Mr. X will be the head of foreign branch office? Okay, so this is a classical case of conditional probability. Probability that B occurs when A is nothing but probability of B intersection A by probability of A. Then I can write it like probability of B intersection A is equal to probability of B occurs when A occurs into probability of A. Correct? Now let me modify this statement to the required form. Probability that foreign branch of what is asked? What is the probability that Mr. X will be the head of foreign branch office? Means probability that foreign branch is opened. Foreign branch opened. Intersection X is head is what is asked. That is nothing but probability that what? I'm sorry, I have to write it in the other way, I think, because it will be more clear for us to understand. Okay, probability that, let me say B is the event that X is head. A is the event that foreign branch is opened. Foreign office is opened. Correct? So, probability that X is head, intersection foreign office opened is what we are interested. Correct? That's what is asked. This is intersection. That is what asked here. Correct? What is the probability that Mr. X will be the head of foreign branch office? That means what? Foreign branch office has been opened and X has become the head. So, X is head, intersection foreign office opened is nothing but probability that X will become head, X will be head, given office, foreign office will be opened, into probability of opening a foreign office, foreign branch. Correct? These two figures are given to us in the problem. Correct? See, probability that a foreign branch office will be opened is 30%. So, probability that foreign branch office is opened is 30%. Then, if it happens, if this happens, probability that Mr. X will be the head of that office is 60%. That means what? This is the conditional probability. If the office is opened in foreign, the probability that X will become head is 60%. So, this value is 60%. So, there is totally 18% chance that 60% is 60 by 100 into 30 by 100. So, this will be 1800 by 10,000, that is nothing but 18%. Correct? 60% is what? 0.6. 60% is 0.6, right? And 30% is 0.3. If you multiply both, you will get 0.18, that is 18%. So, probability that X is head given the foreign office is opened, both have happened, that is, it is 18%. So, that is what is the solution. Clear? So, we are going to move ahead. We are going to see one very important theorem called Bayes theorem on conditional probability. This is a very important and powerful theorem. Okay. Now, the entire trick of Bayes theorem is based on one very important point. For example, I have a set called F. Okay. Set F, and set F complement will always be disjoint set. Correct? See, this might be a very trivial statement, but it's a very powerful statement. This is what is the entire basis for the Bayes theorem. This is what is the starting point of Bayes theorem. If I have a set F and set F complement will always be disjoint sets. Okay, now let me see how I can write this. You will see it to be very interesting thing. Let me say this is my sample space. This is E, this is F. Okay, then I'm going to draw the same figure repeatedly. You will see the meaning in what I am doing shortly. Okay, now let me pick different color. So what is this? This is the set F, correct? Okay. Wantedly I am picking different colors. Now what is this? What is this? This is nothing but set F complement. Okay. Remember that there is a set called E here. Remember there is, okay, let me pick blue, it will be contrasting. There is a set E here. Okay. Now I am going to do two interesting steps. Okay. Now I am going to draw what is E intersection F. What will be E intersection F? It will be this. Correct? I'm sorry. This alone. Correct? This will be E intersection F. Then what will be E intersection F complement? F complement is what? F complement, let me draw it with the yellow color here so that it's very light. F complement is this, correct? This is F complement. The one in the yellow is F complement. Now E intersection F complement means what? Whatever is common to E in that. So this is the part which is common to E, correct? Yes or no? Correct? Now let me number this. Let me call this 1. Let me call this 2. Let me call this 3. Let me call this 4. Okay. Now I am going to do E, F. Okay. So what I am going to do is E intersection F complement union E intersection F. This is what I am going to do. Now you see one miracle is going to happen. What is E intersection F complement? E intersection F complement is what? This part, correct? We got it here, right? E intersection F complement is everything here. Then what is E intersection F? E intersection F was here. Okay. Now what you are observing, these two are disjoint sets. Correct? Because E intersection F complement intersection E intersection F is null set. See clearly the blue region is the one which is showing the E intersection F, and the purple region, the violet color one is the one what is showing your E intersection F complement. So clearly these two are disjoint. They don't have anything in common. See, we are able to see it from the difference in colors itself. Correct? So clearly these two are disjoint sets. And when I take union of these two, what will I get? If I take union of these two, what will I get? I will get this. What I am getting back? What I am getting back is E. This might be, you might be asking what is so great about this. This is a very, very powerful technique for splitting E into two disjoint sets. E intersection F complement and E intersection F are two disjoint set. I splitted up a single set E into a two disjoint set. Now you see what it is going to do. See the power of this now. Probability of E is same as now probability of E intersection F complement union E intersection F. I am taking probability on both sides. These two are disjoint sets. Correct? Yes or no? I think you will be remembering this. N of A union B is nothing but N of A plus N of B minus N of A intersection B. Suppose if A and B are disjoint set, this will become 0. Correct? If they are disjoint sets. Now what is E intersection F complement and E intersection F? Both are disjoint sets. So this will become nothing but probability of E intersection F complement plus probability of E intersection F, because they two are disjoint sets. Now what is probability of E intersection F complement? Okay, let me stop it here and write it in the new page. This is what, okay, let us take this as result 1. We will continue with this. So where we stopped, we got that probability of E is nothing but probability of E intersection F plus probability of E intersection F complement. This was what our result 1. Correct? Now, what is conditional probability? Probability that E F means what? Means what? Probability that E will occur given F has occurred. What will be that? Probability of E intersection F divided by probability of F. So, probability of E intersection F is nothing but probability of E occurs when F has occurred into probability of F. Correct? Similarly, probability that E will occur on E intersection F complement has occurred is nothing but probability of E intersection F complement divided by probability of F complement, implies probability of E intersection F complement is nothing but E occurred when F complement has occurred into probability of F complement. Probability that E will occur having F complement has occurred into probability of F complement. So, if let me call this as result 2, let me call this as result 3, use 2 comma 3 in 1, what we will get? Probability of E is nothing but probability of E when F has occurred into probability of F plus probability of E when F complement has occurred into probability of F complement. This is what is called Bayes' theorem on conditional probability. This is a very, very powerful statement. This is what is called Bayes' theorem. When I know the probability of occurrence of different bits and pieces, I can compute the probability of event on the whole. I know what is the probability of the event F. From that I know what is the probability of, what will be probability of F complement? Probability of F complement is nothing but probability of 1 minus probability of F. So if I know probability of F and the chance of occurrence of E when F has occurred, I can calculate probability of E using this relation. This is what is called Bayes' theorem on conditional probability. Clear? We will solve problem and we will enhance our understanding.